different about the first two questions? How are these different than questions 3 and 4? I'm asking you to find a variable in both of them. Yes, these are the inverses. Remember, with the inverses, you can only have one answer. Sine inverse, its reciprocal cosecant inverse, and tangent inverse exist in which quadrants? You have to have a positive and a negative quadrant. They're all positive in 1, those are negative in 4. Remember, cosine inverse, its reciprocal secant, and cotangent can be in quadrant 1 or 2. So it's different than if I just gave you a problem and said sine of y equals negative radical 3 over 2. They're both asking for the same thing. I'm asking for the angle. This one, though, would have multiple answers. Because the original said an inverse, I can only get one answer. When I see sine inverse, I know it could be only quadrant 1 or 4. Since radical 3 over 2 is negative, I know it's in quadrant 4. Reference angle. When is sine radical 3 over 2? 60 degrees. So in radians, that's pi over 3. So pi over 3 in quadrant 4. So number 2, cosine inverse could be in quadrants 1 or 2. Since it's negative, it's in quadrant 2. Reference angle. When is cosine radical 2 over 2? And pi over 4 in quadrant 2? So it's only when the original problem has an inverse that we are limited to one answer. So the next ones we're solving equations, I'm looking for every time these things are true. How would you solve number 3? Okay, so nothing slip inside. So factoring sine x minus 2 plus 1. What do we have to do now? Add the 2 back. So we get sine x can equal 1 or negative 1/2. All right, we're in radians. Sine. Sine is the y value on the unit circle. When is y equal to 1? Okay, that's the only time. Sine is negative 1/2. In what quadrants is sine negative? Reference angle. When is sine 1/2? 30 degrees, so pi over 6. So pi over 6 in quadrant 3 and in quadrant 4. How'd you guys do on that one? All right, number 4. What would I do? Divide by square root of 3. Negative radical 3 over 3. So in what quadrants is tangent negative? Reference angle. When is tangent radical 3 over 3? 30 degrees, so pi over 6. So pi over 6 in quadrant 2 is pi over 6. In quadrant 4, 11 pi over 6. All right, so these are the types of questions that we were working on in chapter 6. Right. We had the inverse, and then we had solving equations. Do we have any questions on those? Okay, I have 2 more. You guys try the last 2? one, did everybody divide by 2 first? In which quadrants is cosine positive? Reference angle. We're in degrees. When is cosine radical 3 over 2? What happens when you have that 3x? Okay, so my angle, 3x, could equal 30 degrees in quadrant 1 is 30 degrees. Quadrant 4, 360 minus 30 is 330. How do I get my triple solutions from that? Okay, so that gives me 390 and 690. 1150, 1050. Then what do we have to do? Divide all of those by 3. So we get 10, 165, what else? 190. Yeah, I start dividing by 2 instead of 3. And then 130, 230, 250, and 350. Is that okay? All right, number 6. If you don't like thinking about cotangent, you could do tangent. That means tangent is equal to the reciprocal, which is just negative 3. Quadrants, when is tangent negative? Reference angle, do we know when tangent is equal to 3? No. So we go to our calculator, make sure we're in degree mode, and we do tangent inverse of 3. And we get 71.565 degrees. Okay, so x over 2 equals, in quadrant 2, how do I put that in quadrant 2? Subtract from 180, so that would be 108.435. In quadrant 4, we subtract from 360. So we get 288.435. Then we multiply all of those by 2 to solve for x. What were my directions on this? I asked for all the answers between 0 and 360. So the only one that's actually between 0 and 360 is the 216.87. The other one is a solution, it's just not in the interval I was looking for. All right. So that's our review from chapter 6. Let's finish up our homework right now. Okay, so work on that, ask questions, check your answers. So I have my building, and I have a flagpole on top of this building. Okay, and it says we are trying to find out how tall the building is, and it told us the flagpole was 95 feet tall. Then it says from a point on the ground, so the ground is down here, the angle of elevation, remember that goes from the horizontal up, to the top of the flagpole is 35 degrees. from down here, the angle of elevation to the bottom of the flagpole is 26 degrees. And from that, we're supposed to figure out how tall the building is. Now, there are different ways of doing it. We have 3 triangles in this picture. We have the whole triangle. We have this triangle right here. I could draw a straight line. And then we have this little triangle up here. Okay. They share this side in between, so let's call that y. So in my teal color triangle, I know this angle is 26 degrees, this is side y, this is x. This would have to be a right angle. We're going to assume the building's perpendicular to the ground. Our little triangle, okay, this height was 95. This side is y. What would this angle measurement be? 9. You have to do 35 minus 26, which is 9. We can also figure out this angle up at the top by using the entire triangle. Because I know in the entire triangle, this is 90. 90 minus 35, 180 minus 90 minus 35. So this little angle is 55 degrees. Is everybody with me to that point? So, if I'm trying to set this up to find y, I could say 95 over the sine of 9 degrees is equal to y over the sine of 55 degrees. Once you do that, you'll get a number for y. Then you could come over here. This one's a right triangle, so do I even have to do law of sines? No, I could just do SOHCAHTOA. I could say the sine of 26 degrees is opposite over hypotenuse. So you should get a y value. You can plug it in here.